Today we are going to see about serial port programming in assembly. The main objective of this topic is to see, contrast and compare serial versus parallel communication and list the advantages of serial communication over parallel, explaining the serial communication protocol, and we want to see contrast between synchronous versus asynchronous communication and contrast of half versus full duplex transmission and explaining the process of data framing, describing data transfer rate as well as BPS rate, and defining the RS-232 standard and explaining the use of MAX232 and MAX233 chips. First of all, we're going to see about basic serial communication. Before seeing the basics of serial communication, we need to have what is the difference between serial transfer and parallel transfer. The serial transfer, we have a sender and receiver. From the sender, the data is transmitted to the receiver bit by bit. Then it is called serial transfer. The parallel data transfer, where 8 bit of information will be sent from the sender to the receiver at a time. Now, serial communication uses a single data line, making it much cheaper. Moreover, enables two computers in different cities to communicate over the telephone line. The basic serial communication, where byte of data must be converted into serial bits using a parallel and serial shift register at the transmitter side, and at the receiver side we must have serial to parallel shift register so that the data will be transferred. If it is through the telephone line, it must be converted to audio tones by modem. For short distance, the signal can be transferred using wire. Now, there are two methods of data transfer, asynchronous and synchronous. The synchronous method, transfer of block of data at a time. The asynchronous mode, transfer a single byte at a time. And use where, in order to have serial communication, we are using a special IC called as UART. It's nothing but universal asynchronous receiver transmitter, and USART, universal synchronous asynchronous receiver transmitter. The 8051 chip has built-in UART. Now, an important topic when you're making a serial communication or a parallel communication, the data transfer between a transmitter and receiver may be one way or in another or in the two-way communication. If the data is transmitted from a sender to the receiver, if it is on the only one way of communication, then it is called a simplex. If we are transferring data on both sides between a sender and receiver, then it is duplex. If it is not simultaneously, then it is called as half duplex. If we are transmitting data from the transmitter to the receiver at a time or simultaneously, then it is called as full duplex. So we can see half and full duplex transmission in the slide. If the data can be transmitted and received, then it is called duplex transmission. Computer only sends data, simplex. Duplex can be half or full duplex, and depends on whether a data transmitter data can be transferred between a transmitter and the receiver simultaneous or not, then it is called half or full duplex. One way at a time, half duplex. If both ways at the same time, full duplex. Full duplex requires two wires. Asynchronous serial communication and data framing. We are transmitting a data zeros and ones. To make sense of data, transcender and receiver agree on set of rules, protocols, how data is packed, how many bits of data per character, when the data begins and ends, we need to have, so that a framing concept involved. Start and stop bits. In the synchronous method, each character is placed between start and stop bits. A combination of data and stop bits is nothing but framing. A start bit is always 1. A stop bit can be 1 or 2 bits or 1.5 bits. Start bit is always 0. Stop bit is always 1. Now, when you're looking at the diagram, we'll be having mark and start bit always 0. Then 8 bit data is transferred. Then a stop bit is always high, goes at the last. In modern PCs, one stop bit is standard. When transferring a text file of ASCII character using one stop bit, there is total of 10 bits for each character. 8 bits for the ASCII code, 1 bit each for the start and stop bits. So that for each 8-bit character, there are an extra 2 bits which gives 20% overhead data transfer rate. So we know we are transmitting a data from sender to the receiver. The number of bits transmitted per second is called rate of data transfer or data transfer rate. Widely used terminology for BPS, it's baud rate, nothing but baud rate. Baud rate and BPS rates are not necessarily equal. Baud rate is defined as the number of signals changes per second. Now we need to have a standard for making a serial communication is nothing but RS-232 standard, most widely used serial communication standard, where it is not TTL compatible. 1 bit is represented by -3 to -25, 0 bit is represented by +3 to +25, where -3 to +3 is undefined. In order to connect RS-232 to a microcontroller system, we must use voltage converters such as MAX232 to convert the TTL voltage levels to RS-232 voltage levels and vice versa. MAX232 chips are commonly referred to as line drivers.